Okay, so let's talk about solving trig equations, specifically where we have to use trig identities. All right. Okay, before we do that, let's do a little review. So here are reciprocal identities, right? Cosecant 1 over sine, or depending on the context, we could do sine as 1 over cosecant, right? And then here are the others, right? I don't need to read them off. So well, I guess I still will. Secant is 1 over cosine, and cotan is 1 over tan. And again, anytime we can either do cosine equals 1 over secant, or tan equals 1 over cotan. Okay, our quotient. So tan is sine over cosine, and then the reciprocal, cotan, is cosine over sine. Pythagorean, we have sine squared plus cosine squared equals 1. Tan squared plus 1 equals secant squared. Remember, we just divided this whole thing by cosine squared, and that's how we got this one. Then divide this whole thing by sine squared, and that's how you'll get cotan squared plus 1 equals cosecant squared. Let's do our opposite angles. So sine of negative theta is negative sine theta. Cosine negative theta is cosine theta, and tan negative theta is negative tan theta. All right? Okay. And then here, again, we got, remember, we're solving any kind of trig. We're going to get two answers, right? Two solutions within a unit circle, within a circle. So let's see where we get those. So here's our unit circle idea where our hypotenuse is 1. Then given this generic right triangle, sine is y, cosine is x, and tan is y over x. So if sine is y, then it's positive first and second, negative third and fourth. If cosine is x, it's positive first and fourth, and negative in the second and third. And then if tan is y over x, then it's positive first and third, and negative second and fourth. All right? Okay. And then lastly, right, we just talked about some negative and positive angles. So from the positive x-axis, which we'll always label 0 degrees, go counterclockwise for positive angles, clockwise for negative angles. And remember, you can always, if you locate one angle, so here's this ray here, right? So the positive x-axis and this blue line form a 60 degree. Well, I can rotate that line over here by going the negative way too. So I can either go clockwise 60 or go, counterclockwise 60, or go clockwise negative 300, and then that line will be in the exact same place, right? So every positive angle has a counterpart of a negative angle. All right, well, let's go. So how about inverse trig functions? Here's the idea. If you get sine of theta equals 0.5, right, or 1/2, then inverse sine both sides, inverse sine of sine, those negate each other, so you're left with theta, and then you just have inverse of 0.5, right? So you can do straight up calculator, or it's a special right triangle, so we know that's going to be 30 degrees. Well, similarly, if this equation had been cosine, we could have just inverse cosine both sides. If this equation had been tan, we could have just inverse tan both sides, right? So here's the point is if it's sine, cosine, or tan, we have inverses. Well, what if it's something like this? What if it were secant theta equals 2, right? Is there an inverse secant of both sides? That's the question. So I challenge you this, go to the calculator and see if you think there is an inverse secant, go find the button, right? And it turns out there isn't an inverse secant, right? And let's say even if there was an inverse secant, what would we do with something like this? Cosine theta, tan theta, right? What do? We inverse cosine and then we inverse tan, right? That's never going to work, right? So we have a lot of, we have a lot of challenges when things aren't sine, cosine, and tan, okay? Because again, we only have inverses for sine, inverse cosine, inverse tan, all right? Okay, so let's see how this is going to work. So what if we did have secant of theta equals 2? Again, we can't inverse secant both sides because that just doesn't exist, right? So what do we need? We can inverse cosine both sides. So we need to change the secant into a cosine. And since we're given secant, I would use this identity. Cosine theta is 1 over secant. Well, if secant is 2, then put a 2 right here. So cosine theta has to be 1/2. Well, now we're set. We have a nice single cosine, so if cosine theta equals 1/2, let's inverse cosine both sides, and then inverse cosine 1/2. So again, this is a special ratio. It comes from our 30, 60, 90 triangle, so this has to be 60 degrees. And we're done. Okay, so we were stuck at first because we had a reciprocal identity, but we were able to use the identities to turn it into a cosine equation, and then we could solve it from there. Okay? All right, so now let's try this one. Well, I have a cosine and a tan, like I said, and I have inverse cosine and inverse tan, except I can't do it together, right? So I have what I want in terms of cosine and tan, but the fact that there are two of them is really not helpful, So I need to combine these somehow into a sine, cosine, or tan. Well, luckily for us, we have identities. So tan theta is the same thing as sine over cosine. Well, what do you notice? These cosines will divide out, and you're left with sine. So cosine tan is the exact same thing as sine. So that means this equation can be written as sine equals negative 0.5. Well, there you go. So now that I have sine, a single trig function, equals a number, let's inverse sine both sides, and we're going to get, right, negative 30. So it's another, this is a half, it's one of our special ratios. Okay, so there you go. So the gist of this is we need to use identities to rewrite the equivalent equation such that we can take the inverse of both sides. Right? And again, that means it's got to be either a single sine, a single cosine, or a single tan. Okay, let's try this. So I want to solve this. Now I want to go from negative 360 to 360. So I'm going to solve a trig equation. So we should expect 4 answers, right? 2 positive and their 2 counterpart of negative. All right, so I have a tan, which I'm happy about, and I have a sine, which I'm happy about, but I have them all in the same equation, which I'm unhappy about. So somehow I need to combine these two to either be sine, cosine, or tan. Well, I can change tan into sine over cosine, and since I have a sine, that seems like a pretty good idea. I can also change tan into 1 over cotan, but I don't have a cotan over here, so I don't think that's the best idea. So I'm going to go with my first idea. So I have a sine x over cosine x. So now in one step, I'm going to divide both sides by 2 and multiply both sides by this reciprocal. Okay, so that's what this color is. So I divided this 2, and that came over here as the denominator. I multiplied by cosine over sine, which divided out those 2, and then that's why it's a cosine over sine here. All right, so I did 2 steps in one. All right, and notice those signs, they divide out. So I just used some identities and some algebra to make this an equation. Now I can actually solve. So cosine x equals rad 2 over 2. So since it's a cosine, a single cosine, I can inverse cosine both sides. Again, this is one of our special ratios. So, but you can just do a calculator, nothing wrong with that. Then it comes out to be 45 degrees. All right. Okay, so that's our single solution. And so we use trig, the identities, and some algebra to get here. And now we're back to what we've been doing. Let's find the second solution. So this is in the first quadrant. I know cosine is positive in the first quadrant and the fourth quadrant, so I need to make a reference angle of 45 in the fourth quadrant. And if I do that, my other angle would be 360 minus 45. So my other angle in the fourth quadrant will be 315. Okay, and I'm going to show you in the next slide. I'm going to actually show some triangles for these. So if you didn't quite follow along, it's okay. So I found both my answers. So within 0 to 360, these are my 2 solutions. So now let's find their negative counterparts. So I'll do 45 minus 360. So subtract off an entire circle, and you'll get negative 315. Now take this 315, subtract off an entire circle, and you get negative 45. So these 4 angles will all solve this equation. All right. Okay, so here are the diagrams I wanted to show you. So remember, when we solved our very first thing, inverse cosine both sides, we got 45 degrees. Well, what I was saying, right, is cosine is positive in the first and fourth. So this 45 is that first degree angle, right? So go to positive 45. And if you took the ratio of this, this triangle, where adjacent over hypotenuse, if I had these side lengths, it would come out to be this. All right. Well, it's also going to be the same ratio of positive x divided by positive hypotenuse if I go in the negative direction. Right? So that's the fourth quadrant part. And so now how did I get that 315 is I went, oops, I'm sorry. So I'm not quite there yet. So I went from 0 and went all the way around here. So in the positive direction counterclockwise, it's almost going to be 360, but then it's going to be less this 45. Okay. And I do want to point out, when you do these triangles, we don't write for the negative here. I'm just doing it so you can kind of see what's going on. But if I were to do this for real, I wouldn't put the negative here. Okay. All right. So that's the deal. Here's positive 45. That's my first answer. And then from here all the way to here is 360 minus 45. That's the 315 I was talking about. Okay. All right. And then their negative counterparts go this entire way. So that's the negative 315 for this counterpart. And then this counterpart is what I talked about. If you add 360, then that's the 315. Okay, so those are the four, the two positive and their counterpart negatives. All right. Okay, there's only one set of problems, so that's it for the video.